Assalamualaikum YouTube viewers. The topic of today's video is the difference between the radiation chemistry and photochemistry. So in this video I am going to explain the basic differences between the radiation chemistry and the photochemistry. So moving on towards the first difference. The first difference is actually the definition of the radiation chemistry and photochemistry. So what is radiation chemistry? The radiation chemistry is the study of the chemical effects produced in a system by the absorption of ionizing radiation. Okay, so let's just suppose that I have some material here, okay, and it is absorbing an ionizing radiation. Okay, so due to the absorption of this incoming ionizing radiation by this material, okay, due to the absorption of the incoming ionizing radiation by this material, some chemical effects will be produced in this material. So the study of those chemical effects that will be produced in this material by the absorption of the incoming ionizing radiation will be studied in the radiation chemistry. Okay, whereas if I talk about the photochemistry, in photochemistry is the branch of chemistry concerned with the chemical effects of light. Okay, so in case of photochemistry, if we have a material and this material absorbs a photon of light, okay, this material absorbs a photon of light, so what happens? Some chemical effects will be produced in this material by the absorption of the incoming photon of light. So the study of those chemical effects that will be produced in this material by the absorption of the incoming photon of light will be studied in the photochemistry. So the basic difference between the photochemistry and the radiation chemistry is that in photochemistry we have an incoming photon of light, whereas in radiation chemistry we have an incoming ionizing radiation. Okay, so that's the basic difference. So the second point is here that included in this definition are the chemical effects produced by radiation from radioactive nuclei. Okay, so as I've told you earlier that if I have a matter here, if I have some material here, okay, and ionizing radiation is falling on it, okay, so this ionizing radiation that is falling on the matter, this ionizing radiation can be a radiation that is produced from a radioactive nuclei. Okay, this radiation that is falling on our matter, this radiation can come from a radioactive nuclei, okay, or this radiation can be a high energy charge particle. Okay, this radiation can be a radioactive ray that is coming from a nuclei, okay, or this radiation can be a high energy charge particle like electron, proton, neutron, or this radiation can be of electromagnetic wave. Okay, this radiation can be an electromagnetic radiation of short wavelength like that of X-ray that have a 250 angstrom of wavelength, less than 250 angstrom of wavelength, and have energy 50 electron volts. Okay, so this radiation can be a radiation coming from a radioactive nuclei, or this can be the high energy charge particle like electron, proton, neutron, or this can be an electromagnetic radiation of short wavelength like that of 250 angstrom or and having the energy of 50 electron volts. Okay, and on the other hand, if I talk about the photochemistry, generally this term is used to describe a chemical reaction caused by absorption of ultraviolet. Okay, so in case of my photochemistry, the incoming photon is of ultraviolet light wavelength from 100 to 400 nanometer, or it can be of visible light wavelength of 400 to 750 nanometer, or it can be of infrared radiation wavelength of 750 to 2500 nanometer. Okay, so these are the type of the radiation that can produce photochemical effect in my material, and here what I've told you earlier were other types of radiation, the ionizing radiation. Okay, so moving on towards the third point. The third point I have the energy of the particle and the photon concerned in radiation chemistry is very much greater than the energy of photon causing the photochemical reaction. Okay, so the energy of the incoming radiation in case of radiation chemistry, the energy of the incoming ionizing radiation is very much higher as compared to the energy of the photon in case of photochemistry. Okay, so moving on towards the next point. The next point is in radiation chemistry, each photon or particle can ionize or excite a large number of molecules which are distributed along its track. So if I talk about the radiation chemistry, the incoming radiation can excite a large number of molecules. Okay, it can excite a large number of molecules, okay, which are distributed along its track. Whereas if I talk about the photochemistry, each photon excites only one molecule, and by the use of monochromatic light, it is often possible to produce a single well-defined excited state. Okay, so let me describe it by the next diagram here. Okay, as you can see here, okay, on my left hand side is my photochemical process, on the right hand side is the radiolytic process. Okay, in photochemical process, as you can see that my incoming radiation is of ultraviolet light photons, whereas in radiolytic process my incoming radiation are the alpha particles. Okay, so as I've told you just in previous point that the incoming radiation in case of photochemical chemistry, in case of photochemical reaction, the incoming radiation can excite only one atom. So as you can see here, this incoming photon is exciting only this atom, this incoming incoming photon is not exciting any atom, is going all the way through. This incoming photon is exciting only this atom, and this incoming photon exciting only this atom. Okay, so as you can see here that only one incoming photon excites only one atom. Whereas if I talk about the radiolytic process, the alpha particles, as you can see here, the alpha particles as it goes through the material, it can excite a lot of atoms along its path. Okay, similarly as you can see here, this alpha particle is also exciting a lot of atom along its path. Okay, so this is how the photon and the radiation interact with the matter. Okay, so the next thing that I have here is that the low energy one photon one event. Okay, in photochemical reaction, the incoming photon has low energy, means a one photon can only excite one atom. Okay, and on the other hand, I have high energy in alpha. In case of the radiation chemistry, I have high energy incoming radiation, and one photon can excite a large number of events, can excite a large number of atoms. Okay, so this was the basic difference between the radiation chemistry and the photochemistry. So inshallah, see you in the next video. Do not forget to like the video and subscribe the channel. Thank you and Allah Hafiz.